Thanks everyone for coming along. Good morning. What I'm going to talk to you about today is, well, my favourite subject. It's the area of psychology that really got me really hooked, and it's why I'm here today, which is all about understanding the role of evolution and genetics in terms of psychology. So that's what I'm going to do in today's lecture. First half, I'm going to look at evolution. Second half, we're going to look a bit about genetics and the role they have there. So I'm going to start with, in this first part, going through why I think it's really important to have an understanding of evolution, thinking about things in evolutionary terms when it comes to psychology. I think it's a key part of how we can really get to grips with why our psychology is the way it is. So to do that, I'm going to give you a bit of a potted introduction to things like natural selection, particularly examples of natural selection in humans, and how that can apply, and thinking particularly about our own psychology and the way we behave and the way we think. As well as that, I'm going to talk to you about the history of humans, our evolutionary history, so get a good idea about what sort of things our ancestors went through to get through to here, and what sort of psychology they've provided us with. And also, I think it's always important to look at what is unique in humans. To find out what's unique in humans, it's always important to look at what's it like in other species. I'm going to talk you through briefly some of our close relatives, other primates, other apes. And we can finish off with talking about some things that are universal to all humans, and why that's important in terms of saying that these things are evolved in our nature. So I'm going to start off with evolution. And I'm going to start off with a question. What's this for? This tool here. What is it for? Now, I'm going to get you to put your answers in. I'm going to use something called Poll Everywhere. So if you just go on your tablets, if you go to pollev.com, then /D Farrelly, have a guess. What do you think this particular tool is for? I'm going somewhere with this, trust me. It's not well, it is kind of a trick question. I just want you to have a think, have a look at it, look at different parts, have a guess at what you think this tool is used for. Good start. So we've got punching holes in belts, a nut opener, nutcracker, very Christmassy themed here, isn't it? Yeah. Quite right. Poking holes in leather. Yeah. Medical equipment, nice and vague, I like it. You could probably do something quite medical with that. I don't think anybody particularly like it, what you did with it, but it could be. Yeah, belt hole puncher. Yeah, so you're going about it the right way, you're looking at it, you're thinking about it. I say, so maybe you could just put the belt in there and clip down. And it's not very sharp. Do you think that would puncture a leather belt? Could do. The answer about what it actually is, it's an olive pitter. So what you do is you put a little olive in there and you press down and the pit comes out of it. Just gets the seed inside of it out. That's what it does. That's why you can see it. And why I'm asking you that is because now you know what it's for. You understand what its purpose is. You can look at it and you go, okay, you know, the people saying it's definitely something for punching holes in. But you think, okay, well, actually, it's a bit blunt, so maybe it wouldn't pierce through leather, wouldn't really get through a nut either. So I think, okay, it's probably something a bit softer than that. Now we know it's an olive pitter. So we know, oh, yeah, perfectly, an olive will fit in there. That'd be nice, and it'll just come out, shoot out there. Now, once you know what a tool is for, you can understand how the different parts work. You can understand how it functions. You can understand why it's designed in that particular way. And that's just the same when we think about our brains. We need to think about, well, what are our brains for? What purpose do they serve? Why are they in the current state that they are after millions of years of evolution? And the answer is our brains have been shaped by evolution over that period of time to help our ancestors and us solve problems that we faced. And those problems would have helped us survive, helped us reproduce, so we'd have offspring who would inherit those same genes that create the same brains. That's what evolutionary psychologists do. We think about the brain as being something that's evolved. We understand what it's for. And once you understand what it's for, you can work out what all the different parts are. Now, too much time in psychology has been spent not really thinking about what the brain's for, just trying to understand it. So looking at the different parts, looking about how we think about things, how we understand things, which we don't always do very well. Once you know what it's for, it makes it a lot easier to do. So that's why I think it's really important. In order to do that, we really need to have a grasp about, well, how does evolution work? How do we actually get to the stage where our brain is designed for a particular purpose? It all comes down to natural selection. So this is Darwin's idea, Charles Darwin's idea, that evolution happens by natural selection. And for him, there's 3 parts to it. First of all, there's variation in a trait. So any particular characteristic could be intelligence, could be height, could be anything. If there's variation within a population for a particular trait, then what will happen is we'll be able to act on it. So some will be more successful, some will be less successful. But what will happen is those that are successful will be more prevalent in future generations. The other point is inheritance. Those traits need to be passed on to future generations. So any trait you do have with it variation needs to be passed on. So things like your height, your intelligence, which is by and large passed on, needs to be inherited by your offspring. But this last one is the most important thing, selection. What we should have is that the ones that are best, those particular variations that best help individuals survive, help them to navigate around the world, help them to find a mate, find a partner to whom they can then have offspring with, to inherit those things, are going to be really key. So this is Darwin's idea, natural selection, really simple idea. Very easy to grasp. It was nothing ever complicated, but just the sheer understanding of it is quite difficult. What I'll do is I'll give you some examples so you get a good sense of it. Right. I'm going to ask you a question about which things you find more scary. Anybody really got a real fear of spiders? Okay, if you have, you might want to close your eyes for just 5 seconds. So is this scary? Even of those of you who don't have a fear of spiders, have some urges. Yeah, we're scared of spiders. Now, who's got a irrational fear of, or real phobia of, pictures of prescription pills? No, you don't, do you? Which is more scary? Spiders or prescription pills? The answer should be prescription pills. These are much, much, much more likely to kill you than spiders are. But we still have a real fear of spiders. The reason is throughout the vast majority of the history of humans as a species, we've had a fear of things that will kill us, and quite rightly so. If you have a fear of spiders or things that look like spiders, and you run away from them, or you stay away from them, that's fine. If you don't have this fear, and you wander up and go, oh, there's a nice little thing, pat it on the head, it bites you and you drop down dead, that's not very good in terms of passing on your genes to future generations. Dropping dead is never great. So we evolved this fear of it, because those that ran away from spiders, avoided them, were much more likely to survive. And we've inherited that fear. We still have it now. My daughter's 2 years old. She's got a fear of spiders. I try to instill, I go, oh no, it's cute, it's a little baby, little spider, it's lovely. She's like, no, spiders, no. And trust me, I've checked, there are no venomous spiders in this part of England in 2018. We're all fine, there's no fear. There's nothing to worry about. But we still have the psychology of being fearful of them. And that's not going to go away anytime soon, because there's no need to. We should have this fear of prescription pills, much more likely to kill us, but we don't. We shouldn't have a fear of cars. We stand at the side of the road with cars whizzing by at 30, 40 miles an hour. We just sort of look out and go, oh, I missed it. If it was a 100-foot drop, you wouldn't just go, yep, oh, it's quite far down. We'd stay right far back, because cars were never really a problem until the last sort of 50, 60 years. And our psychology hasn't caught up with that. That's how natural selection works. There'll be variations in levels of fear of spiders, and that'll be inherited. And those who had a real fear were much safer, much more likely to be, less likely to be bitten, and their offspring would inherit that. So which is the case now, we've all got this rational fear of spiders. Here's an easy one. Which of these is more delicious? Is it the sight of chocolate, melted chocolate? You can almost taste it. Okay, those of you who skip breakfast and we're really feeling it now, nice and delicious, coming up to Christmas, think about all the chocolates you're going to have. Is that more delicious, or a picture of broccoli? Now, the answer is chocolate, because everybody hates broccoli. Nobody likes broccoli. People say they do, but you're lying. Don't lie to me. You hate it. You love chocolate. Which is right. That's the right thing to do. Think back for the huge amount of time that we lived as a species.
What we needed is sugary, fatty foods. That gives you the energy, gives you the nutrients to survive, be able to, to actually get on with your day-to-day life. But it would be so scarce. And one thing that would really help is if you had a real drive to find sugary, fatty foods and eat them. And you found them really delicious, you'd remember where they were and you'd go back to them. It works really well because make sure that you actually get those. Those individuals who had that love of chocolate or love of sweet foods would be more successful than those that didn't. Now, fast forward to 2018, chocolate's everywhere. I mean, you could walk to the canteen, but if that's too far, there's a vending machine just over there. There's a cafe just there. There's no problem finding fatty, sugary foods, which is a problem for our health. And if you go to the vending machines, they're stocked full of chocolate. They're not stocked full of broccoli, because that would be stupid. Nobody would buy it. We should be eating more broccoli. That will help your survival, but it's only very recently that it's changed. And now we should really be craving broccoli. Say in sort of 100,000 years, the vending machines, or whatever the equivalent is, the vending machines will be full of broccoli, because that's what everybody loves. And you have to force eat your chocolate. Oh, you're gonna have one piece of chocolate before you can have your broccoli dessert. Okay. But at the moment, it doesn't. We don't need it yet. Eventually, it might catch up, but it won't. That's why we don't crave foods like this, but we crave foods like that. And that's natural selection. You can see that immediately. Think about that. That is how natural selection, how evolution has shaped your psychology. And it's shaped lots of other things. It shapes how we view things. How do you feel about this? This is a snub-nosed monkey. Now, snub-nosed monkeys live in China, in rainforests in China. And they live in groups. They tend to live in groups. And what they do is they sort of huddle together in the rain when it's cold and horrible. I mean, this one's obviously on its own, so it's probably an orphan. Its parents died and those sorts of things. Yeah, and they all sit like that in groups, sort of hugging each other. They're endangered, though, like most parts in the world where we're reducing the amount of rainforests with deforestation for agriculture. Their homeland's depleted. So if we set up a fund to support the snub-nosed monkeys and I passed a bucket round and asked you to make a donation, you'd look at that and go, yeah, I'll help those guys. I can show you another picture of snub-nosed monkeys. Oh, he's lovely. And you go, oh, okay. Well, maybe I won't give money. So you look at that and you think, that's not as quite. But don't forget, give you money, but no, don't worry about it. I know Christmas is coming, but forget about that. But they all need our support. You can go like that. And what happens, and you can do, it's great fun. Our brains are hardwired to respond to these things. Because look how young and neotenous it looks. In other words, it looks very, very baby-like, which is what it means. And we respond to those things because we're a species where we have to care for our offspring. They're really difficult to raise. So it's good to have a real positive feeling towards things that look like babies. And this monkey does. And it's not necessarily always humans. If you look at young of any species, you find the same thing. They all kind of look the same. They've all got the same features of like quite big eyes, big forehead, quite small lower part of the mouth. And we respond to it in the same way we respond to human babies. We feel the same sort of cuteness. We feel a warmth towards them. And it works very well for human babies because if you feel warmth and love and affection towards them, you're more likely to support them and help them. And they really need it when they're little. But the fact is we have it for anything that looks young. All these species, and it works for any species, trust me. Platypus. Even little stingrays. Even though they do look a bit like ravioli, but they look cute things. That's your psychology kicking in. That's that drive to like things that are neotenous and they're cute. It works because those individuals in our history who had that drive were more likely to take better care of their offspring. Those offspring would be better when they grew up and pass on that and so on and so on. Other people have worked out this is right. Walt Disney worked out this is right. So this is Mickey Mouse. I forgot who it was. Yeah, you should know who Mickey Mouse is. This is the original Mickey Mouse here on the far right. He looks like a mouse. Looks quite rodent-like. But over the years, it's evolved, and it's got more and more neotenous, just like the baby features. If you look at them, like that, big eyes, big forehead, lower spot of the mouth, that's exactly what Walt Disney did. And that was, that was a response to, making it more desirable, and eventually for Walt Disney making more money out of films and of merchandise in his resorts. But again, that all plays into our evolved psychology. We know these things. We know how we respond to that. And it affects lots of different things. So that question I just asked you about, when I passed the bucket round for the Snubnosed monkey, and you give some money to charity. Now, if I ask you, this is part of the time of year where we have a good season of goodwill to all, and if I asked you, after you give money to that charity or some other charity, and I said, why did you give that money to charity? Most of you respond, went, felt better for doing it. Gave me a nice glow. I felt sorry for the person. Which is right, that's the correct answer. That's the correct sort of answer you'd expect to give. But what I'm interested in is why you get that warm feeling, why you get that sense of heightened mood from giving to charity. Because there must be a reason for it. Why are you giving away your money in order to feel good? That doesn't make sense. So we need to understand that. And this is where we look to other areas of psychology, or other ways where we study behavior. So we look to the ethologists. In other words, the people who study animal behavior. And one guy here, Nico Tinbergen, he famously tried to understand all aspects of animal behavior as being at different levels of causality. In other words, there's different levels at which you can understand the behavior. And it's sometimes called his 4 whys. So you say, why do you give money to charity? You can answer that why 4 times. You can answer it in what's called a proximate or mechanistic way. So in other words, you'd say, well, I felt good for doing it. I ate chocolate, it made me feel nice. That spider made me feel really scared. That's the immediate response. And that's what most people would answer with. You could answer in what's called also the developmental or ontogenetic case, which is how you might answer it in terms of your history as an organism. Say, well, I know from a young age that chocolate is really delicious, and I learned to love it, so that's why I ate it. You could ask it from a historical or phylogenetic course, so talk about it in terms of the history of history of humans. Say, well, humans have evolved to digest particular sugars and fats in high concentrations, and this is a good sort. I mean, a bit of a strange answer to the question is like, why do you like chocolate? But it's still a legitimate answer. This last one, this functional or ultimate cause, this is what I'm interested in. When you look at psychology from an evolutionary perspective, this is the most interesting one. Because that's saying, well, why? What's the value of it? Why is this adaptive? Why is there a benefit for you eating chocolate? And the answer would be, well, I need that energy. It's a good energy source, and I need that to be able to survive in a particular environment in order to have offspring who inherit this love of chocolate. Again, it's a weird answer to the question. If you ask someone that and they said that, you think they're a bit weird. But that's what I want to understand. So thinking back to why we give money to charity, you can answer those 4 questions, that question 4 ways. Firstly, the proximate way, it makes me feel good, it lifts my mood. And that's what happens. When we give money to charity, it does make us feel good. And you put money in a bucket and they say, do you want a sticker? And you go, no, I don't want a sticker. You do want a sticker. Take the sticker. Wear the sticker with pride. You go, oh, okay, I'll take the sticker. And you just go, I want a sticker. Everyone loves stickers. Or you could answer in a developmental way. Well, charity has been a norm in the culture that I live in. So, you know that you give money to charity and that's something that's expected, that's something that's rewarded and positive. You do it. Or you can say, well, my ancestors benefited by being charitable. They entered into collaborations with different individuals, and that was successful. And as a result, they have these emotional urges. Our emotions change, which drives us forward. The last one, the function. What's the ultimate reason you give money to charity? Well, there's a number of different things. Firstly, you could be signaling your charitable nature. So, look, I am a charitable person. I will give money to this individual. So others may see, oh, this would be someone good to trust, good to work with, good as a potential partner. Or it could be the fact that, well, I know that we need as a group to be successful. So to do that, we need to support each other. And if I support this individual, I'll get support back from them. And as a result, people will be better off. People will be more likely to increase their own likelihood of surviving by cooperating with each other. And we will. Cooperation is a big part of our psychology and our evolved psychology. we did much better in groups than we did on our own. So it spills over here. So exactly the same question answered in 4 different ways. Most of the time in psychology, it's the first one. You think about, well, we help other people and it makes us feel good. Okay? But why? That's what I'm really interested in, going, why? A bit like a toddler going, why all the time. That's evolutionary psychology. We're annoying like that. But we need to know why. Well, why are we like that? That's the ultimate thing. That was what, for me, when I was studying psychology, when I was like you guys, actually I did want to know that. I wanted to know, well, why are we studying psychology? Well, why is our psychology like that? And that was when I studied evolutionary psychology, and it all came clear to me. So for next up, we're going to look at our evolutionary history. So I think it's important that to understand our psychology has evolved, it's important to understand us as a product of evolution. Look at our evolutionary history. Think about who our ancestors are, or what we know about our ancestors. What were they like? How were they different from us? How were they similar? How did they develop? And also think about, well, what's the first point at which we can say there's a human here? And however we define that, which is a really important point. So let's look at our ancestors. Let's go through them. First off, we got the Australopithecines. So this was the first species we know about when humans and chimpanzees in their earlier form split off into the 2 different branches. Probably with, we changed habitat. The first species we know that's different in the human line are the Australopithecines. And they weren't that much different than modern day chimpanzees. They were similar sort of size, could maybe walk on 2 legs, which is an important point. Probably still lived in trees. Brains not that much bigger. So not much difference. But you can start to see, particularly in terms of their physiology and their physique, starting to appear a bit more human than, say, other chimpanzees or other apes would do. After that, we've got the first Homo species, getting to Homo habilis, who lived about 2 million years ago. This is where we really start to see some really human traits come in. First, he was called the handyman because lots of tool use was evident here. So quite often find in remains that lots of tools, particularly hand axes, we use. So when we start to use tools, suggests we started to be able to think differently. Our cognition changes. Getting a bit bigger, so about 5 foot tall, 100 pounds, so still, still a lot smaller than modern day humans. Probably walked on 2 legs, really important thing for us, and ate meat, which was a change. So all the other great ape species don't eat meat or don't eat meat regularly. Humans did, and that allowed us, gave us a lot more energy to change. And the brain's getting bigger. And also there's some evidence from the shape of the brain that certain parts of the brain that relate to speech that we have modern days was growing, was developing. So maybe they could start to use speech. And so maybe we're seeing here the origin of language in us as a species. And then we've got Homo erectus, which is about 2 million to about 300,000 years ago. So really quite recent. Using more tools, using fire, other things like burying the dead, using art. So lots of cave art coming around. And very much like modern humans, only the head and the face were slightly different, so a bit more of a pronounced brow ridge and a lack of a chin. Brain getting a lot bigger. So the size of brains in these human species grew very, very rapidly. It was a massive increase in brain size. Okay? And that's where our psychology comes from. So it was really interesting to see how fast it happened. And that's probably our direct ancestor. Now, this is, you don't think it went like that, 1, 2, 3, and then, whoop, one day modern humans arrived. This is a better idea of the different human species, starting with the Australopithecines here, and some of them tend to other forms of Australopithecines, and Homo habilis came here, and it's a bit, as it gets nearer, it gets more of a mess. So we've got Neanderthals there, we are not our relatives. We've got Floriensis there, Homo erectus, and Homo. So it's a mess. But where would you say humans first arose? There's no point here where we say that's where humans came from. That's the start of humans. And you wouldn't expect it. So when people talk about things like the missing link, it's rubbish because, of course, there's a missing link everywhere. And we know all these things from fossils, from fossilized remains. And the fossil remains are really quite remarkable that there's any fossilized remains at all, or we can find them. And there's very few entire skeletons that are preserved. So the Australopithecines, everything we know about them is based on just one skeleton that was found almost 50 years ago, called Lucy, in Africa. And that's all the remains. And from that, from looking at things like the size of the femur, the size of the pelvic, be able to work out lots of things like, did this species walk upright? Did not. Would you look at the size of the arms, or were they actually still living in trees? When people talk about the fossil records being incomplete, of course they're incomplete. It's really difficult to find anything fossilized, but we are finding things I'm not going out finding, other people like me, well, not like me. I'm reading about it. And one really interesting one that I read about that wasn't involved, I'm glad I wasn't involved in this one. A couple of years ago, in this cave in South Africa, a new species, possibly new species of early humans was found called Homo naledi. And to get there, anthropologists had to go through there and crawl through this area, which is just 20 centimeters wide, and another bit there. But when they got there to this cave here, they found lots of human remains of a species that, sort of, not quite sure how old they were, but they weren't clearly modern humans. Anatomically, they were different, but all the remains were there. And it was fascinating discovering, we're still trying out lots of things about them. But then the question asked is, how did they get there? If this is so small, how did they get there? Now maybe they crawled in there when there was a flood or something to protect themselves and got stuck or drowned. That's one view. Another view is maybe they were buried there. Maybe they were buried there alive by other species. It's really interesting. I've spent the whole lecture talking about fossils, but I think it's a fascinating area. But luckily, there are people crawling through these little tiny gaps for us, so we know about these things. From that, we can know a lot about our own ancestry, our own history as a species. And from it, we can know a bit about where we lived and the environment we lived in. We know that for a huge amount of our evolutionary history, we lived here. It's on the right-hand side, the Great Rift Valley in Eastern Africa, which is modern-day Kenya, Somalia, Ethiopia. Just this area here. And we lived in what was called grassland savannas that looked a bit like this. Not completely, though. Probably had more trees. This is what it looks like now. So from about sort of 2 million years to about, say, 100,000 years ago, probably earlier than that, that's where we lived. It's a huge amount of our evolutionary history. We lived there. The amount of time we've lived in, say, Northern Europe is, it's barely in a blink of an eye. And the sort of societies we lived in is what's called a hunter-gatherer society. So you hear people talk about hunter-gatherers. That's what it was like. We lived in environments like this, probably wasn't quite as idyllic as that, of about 100 to 200 individuals in a group, in a clan, living together, which includes your immediate relatives and other group members, other people you worked with, other people who you interacted with regularly, hunted with. And it's hunter-gatherer, and there was a division of labour between the sexes. So the males in the group were hunters, so they go out hunting in large groups. Women were gatherers, okay? But also women did quite a lot of hunting. Actually, quite often women were more successful at hunting than men. The men would quite often hunt really big things, be unsuccessful, as much as men do nowadays. They try to show off and fail miserably, while the women do all the work. Some things haven't changed. So that's what we think about when we talk about the environment humans evolved in. Is that everything that happened here, and when we lived in groups like this, all the problems we faced here, be it interacting with groups, trying to find a mate, avoiding predators, finding food, learning to understand each other, it all happened in environments like that. And it's only very recently where we moved to modern sort of Western societies like this, completely different. So how do we know we lived like that? Well, we know that quite a lot from archaeological remains, but we also know it because there are still humans living almost completely like that in modern times. Here are a couple of pictures from a few years ago from a plane that was flying over the rainforest in Brazil and the border with Brazil and I think with Peru. Huge area of the rainforest around the Amazon, completely unobserved. We don't know anything about it. So in order to try to understand it, so see what we could do, they sent off a little plane because they knew that there were some groups of humans still there somewhere. In order to find it, to be able to stop the deforestation, to protect these groups, we need to know where they are. So they flew over and eventually found this little clearing. And they saw that there were some huts there. There was no record of this, no knowledge about this at all. So they took a few pictures from the plane. And then they went a bit closer and took some more pictures. So you can imagine what it was like. So this is a group who, well, it turns out there's no record of them interacting with any other group of humans for the last, I think, 200 years. And you can see, completely untouched. So you can imagine all of a sudden this big metal plane is flying over them. So send out the hunters, which are all the men, who've managed to get themselves all dressed up. They've got their bows and arrows. I wish them luck against the plane with a bow and arrow, but they don't know. This completely new thing, this technology they haven't seen before. And we look at it and think, okay, well, you can see there's, all these groups sort of living in probably enough for about, similar-sized groups to what we'd expect from ancestral groups. And it clears to see there is a division of labour, that there are all the men ready to do the hunting. So we can say from that it's probably quite similar to what we predict our ancestors were like, because it's still the case that they are living like that in modern days. So, the issue now as psychologists is trying to understand how everything that helped us here, all aspects of our thinking, of our behavior, of our knowledge of the world, which helped us survive here, is still relevant now in modern life. Because we've got exactly the same psychology that would help us here, and it's here. Okay? So we're now living in an environment completely different where you've all got up early in the morning and it was dark. Why did you get up when it was dark? Your ancestors didn't get up when it was dark. We're all pretty stupid for doing that. And you travelled in and you sit inside, and because we live in a part of the world where you can't survive without heating, and it's getting to the stage we can't survive without air conditioning in the summer, so we all have to be indoors, and we're all sat underneath the artificial light, we're looking at a screen, and it's a week before Christmas. What are we doing? So it's really bizarre, but we've still got exactly the same. We've still got this fear of spiders. We've still got this love of chocolate. And it's all there, but we have to live in this new environment, this new world. So that's what we're really interested in, is understanding where there's this mismatch between it and find about how aspects of our psychology maybe still work quite well and other aspects where maybe it doesn't work quite so well. And that's what we as evolutionary psychologists do. That's humans' history. Now I want to talk a bit about not just our history, but how we compare to others who are with us now. Nice, easy question. To get you an understanding about it, which of these is our closest living relative? Is it the gibbon, gorilla, chimpanzee, orangutan, or baboon? Got another little poll to do for that. It's a bit bizarre, this one. If you just go to polev.com/Steve Farrelly, just select which one you think was best, most likely to win Strictly Come Dancing, or our closest relative. And let's see what we know. And a clear win for chimpanzees. Correct. Chimpanzees are our closest living relatives, followed by gorillas, then orangutans, gibbons, then baboons. So all our relatives, all part of the primate order. Quite an easy one. But what if you look beyond just our own species, our own order of primates? Here's a tough one. Put these species in order of relatedness to humans. So closest relatives to us first, furthest relatives last. We've got dolphins, rhinos, and tree shrews. So, I'll set this up. quite easy to do. Ooh. There. So if you think it's dolphin, tree shrew, rhino, text that code or put that code into, oh, activate it, into poll everywhere. If you think it's tree shrew, rhino, dolphin, it's that one. Rhino, dolphin. Anyway, you can see them. You can work it out. So not as easy a question as the last one. And I just try and remember what the right answer is. Yeah, I've got it. The correct answer. People stop finishing. People still going. Oh, finally, someone's got it right. It's the last one. It's tree shrew, dolphin, rhino. We are more closely related to tree shrew than the other two. Don't always base it on what you think is most likely, based on other characteristics. The tree of life is incredibly complicated. We are just one small part of it. And this is a sketch that Charles Darwin actually did in his notebook. Previously, we used to think that humans were at the top of it, that, the tree of life, everything aspired to be humans. We were the most important thing. And we were created in the image of God. But he was saying, no, we're just one small part of this huge tree of all species. And now there's a really interesting website here where they actually map it. So if we start from, let's start, oh gosh, where are we going? Yeah, it makes me a bit sickening. That. Go all the way into mammals. Are we going into dogs? Are we going? All right, we're starting with dogs, apparently. Let's put in humans. You put in humans. You find out where we are. Yep, humans. There we are. We're not, we're not under conservation. We're least concerned. But then you just scroll back. And there we are. There's all the primate species. So there's chimpanzees, all the apes. There's all the New World monkeys. So all the monkeys and apes, all the primates, and then we've got the, all the primates there. So we've got all the lemurs there, and the tree shrews. There they are. We're very closely related to tree shrews. We go back over here. Dolphins and rhinos are there. You just drag out and drag out. All of a sudden, you get a bit of perspective about our place in it all, which is very, very tiny. All the different species there are, all the different orders there are. We're just one, we're at the very apex there. All the different species. And this was something that Darwin realized, which other individuals maybe didn't, that actually we are just one part. We are one species amongst many, many, many. And that's how we should think about ourselves. We should compare ourselves to other species, because that's what we are. We are a species of ape. We are a species of great ape. And this is where we split. These are all the apes. So we've got the gibbons here, which are otherwise known as lesser apes. Then orangutans split, then gorillas. And then here's the split between humans and chimpanzees. We split there about 6 to 8 million years ago. That's when the ancestors of chimpanzees and humans split off. So everything that's interesting about us, unique about us as a species, happened in this period here. This rapid growth of brains. Other things like language, other aspects of a change happened here. But it's still always important to compare ourselves to what's happened here, because we are very, very similar to these other species. The different great apes have different ways of living as well. Orangutans, they split from humans about 8 million years ago. They live in Asia. So the only species of ape that didn't really come from Africa. They live a solitary life, so they don't live in groups. They tend to meet just for mating. They're arboreal, so that means they live in trees. Spend a lot of time living in trees individually. Then we've got gorillas, more closely related to us than orangutans are. They live in Africa. They're very large. They don't live in trees. They live on the ground. They forage on the ground in forests. And they start to live in groups and not as individuals like orangutans are. Then we've got chimpanzees, our closest relatives. They came from the same part of Africa, well, same-ish part of Africa that we did. They moved a bit west, we moved east. They live in groups. They have very complex societies. And there's two groups, there's chimpanzees and bonobos. Bonobos are even more closely related to us than chimpanzees. They're called, otherwise known as pygmy chimpanzees. But they have big differences. So there's your normal chimpanzee, your Pan troglodytes, and there's bonobos, Pan paniscus. The social behavior is very strange. For chimpanzees, they have very complex hierarchies. They live in groups. Anybody who watched Dynasties a few weeks ago, you'd have seen that's a really complex hierarchy that chimpanzees live in. Really difficult to understand, so they are quite intelligent. Bonobos, less so. They're much more free, much more easygoing. Very famously use sexual acts as a greeting, as a hello, how are you doing? Good to see you, sorry about that. They have sex with each other. It's very, very strange. It works for them really well. But they are still very social. Chimpanzees mostly eat vegetation, but eat some meat. Bonobos completely plant-eating. There's difference in sizes of them. Intelligence. Now, bonobos are more intelligent than chimpanzees, and they have a better ability to use language or communications than chimpanzees do. So, even though they're very similar, we're slightly more related to bonobos, and bonobos are slightly more like humans than chimpanzees, if you think of it that way. They're more intelligent, more likely to have language, more likely to walk upright, and those sorts of things. So, what is special about humans? Why are we so special? Why do we think we're so unique? And we are unique. But what is it about us that we're unique? What do we need to study in that line from 6 to 8 million years ago that makes us as a species unique from other apes? Well, firstly, our intelligence. Okay? Our brains are 3 times the size of chimpanzees related to body size. So that's a huge increase in brain size over a very, very small period of time. With it came this great intelligence that we have. We've got language. So we've got a very rich form of communication, which is things like grammar and syntax, much different than, say, normal gestural communications of shouting and barking. We have a theory of mind. We understand the intentions of others. We can know what another individual is thinking. They can know what we're thinking. All part of us being a really social species, we're able to understand these things. Our high sociality as well. If we really understand what is special about humans, we need to understand that we're an incredibly social species. Okay, that is the key thing. Everything to understanding our psychology, the way we think, is knowing that we're very social. And we walk upright. There's a physical difference. We walk on 2 legs. That had a huge difference. It could change so many things in our lives. Straight away, as soon as you start walking upright, you can see people. Your hands are free. You can start using different things. And also, we started eating meat, which is a really good source of energy and protein and other nutrients that you need if you're evolving to be bigger, particularly if you're growing bigger brains. You need that high amount of energy. We were only able to do that once we started eating meat, get that amount of energy in. So all these things happened that made us unique. Now from that, what I'm taking you through is our evolutionary history, saying what humans were like, saying, well, we're completely different now, but we still got the same psychology that we evolved with. Now that's different from what other species have. So what I want to talk to you now is a bit about, well, what is universal amongst all humans? Now, why this is important to talk about human universals is these are traits that are shared by all humans on the planet. All humans have some traits in common. So it could be things like expressions of emotions. A happy face is the same no matter where you go. Now, if we say that a trait is universal to all humans, it means it's something that's not been shaped by the culture in which that human lived. Okay, so if it just so happens that every culture on the planet, this means happiness, maybe not so forced. Smiling means happiness, then there's no way that culture could have done that because culture has done it exactly the same way everywhere. So we say it's unlikely that there's any role for culture or society there. Instead, we say it's much more likely due to evolution, that all humans evolved the same way of understanding and expressing the emotions. And that happened over millions of years. Then after that, we left, came out of Africa and populated everywhere around the globe. We still have that way of expressing emotions. They still have that way of understanding emotions. And that'll be everywhere. It might be traditional society, so I bet if they actually did go to that group in the Brazilian rainforest, which fortunately they don't, a smile will mean exactly the same thing. Okay, and it's same as it means here. So what other things are universal amongst humans? Well, this is what evolutionary psychologists are interested in. We want to understand these things that are universal, and we can say these things are part of our evolved psychology, and that's how we should really understand them. And there's a few things that are, and I've just picked off a few that are probably good examples. Firstly, an ability to learn a language at a young age, a very young age. Okay, so we all learned to speak around the age of sort of 2. And you learnt a language, what the language you were encountered, the environment you were in, very, very rapidly. Your vocabulary increased hugely. I mean, I've got a 2-year-old daughter at the moment. It's incredible how quickly she knows things. She had a picture of a mole, and you go, what's that? She go, a mole. I went, where have you learnt mole? I haven't taught you mole. She just picks it up incredibly quickly. Now, try and learn that language as an adult. It's really difficult. You can't do it. We can do it, but it's hard work. And you have to try and understand it. But a 2-year-old can do it. That's because their brains have evolved to be able to understand languages very, very quickly. It's something called universal grammar, this language acquisition device we have. And it's incredible. It really is incredible. And all humans have that. Other things, newborn babies can distinguish between faces and other objects, and that's after 24 hours after being born. They're more likely to look at mobiles that have faces on them than mobiles of other objects. And, like I said earlier, we're a very social species, so that makes sense. We need to be able to respond to faces, know what they're about, and judge them. We're also very likely to be cooperative, and we form groups that are cooperative. So if you go to any society, you find there are norms about cooperating. Individuals will cooperate with one another. Because there's a benefit to doing it. You're much more likely to be successful and survive if you cooperate and help each other than if you don't. Our expression of emotions, the way we understand emotions, that's universal. And you find that in all societies. Other things about sex differences. So we find that men are more violent than women. Again, this is something that's universal, so it's not necessarily a cultural thing. Culture will shape it, culture will alter it. Maybe how it's expressed, the prevalence of it. But in all cultures, you find men are more violent than women. Again, that relates to things to do with the division of labour, to do with hunting, to do with the differences in terms of mate choice. Men tend to compete with each other for women, for partners. So that competition gets fierce and can get violent. And the last one is what we find attractive in other individuals. So men tend to prefer physical attractiveness in their partners, or women tend to prefer signals of resources or status in potential mates. And this is always a good one to think about, because we always judge the other sex as being shallow. For them, oh, she's only interested in him because he's got lots of money, or he's only interested in her because she's good looking and attractive. But the truth is that's what your ancestors did for millions of years, is they picked those individuals, and they were quite successful for doing that. So actually, it's not a bad thing. We judge it indifferently. But actually, this is what happens, and that's universal. You find that in every single culture around the world. So that's why I want to leave it for this first part. Hopefully that's given you like a bit of an idea about, well, why I think evolution is important to understand psychology, that we need this as a basis for it. And the fact is that, well, maybe we don't, maybe we should eventually. Looking at it through some key aspects of it. So getting this grasp of natural selection. It is a very simple idea. When Darwin came up with it, other biologists were annoyed because it was such a simple idea about how life evolved on the planet. But understanding it, really appreciating it, particularly when it comes to humans, is difficult. And that takes some doing. But hopefully there's examples of natural selection that are really immediate. Our love of sweet, sugary foods, our fear of spiders and snakes. Gives you a clear idea, well, actually, yeah, that makes sense. They can see how that's evolved and why that's still with us in present day. And thinking about our evolutionary history. Okay, so we need to have that ground about where we came from to understand, well, what's different now? Where did these things like language, intelligence come from? And then comparing it with our close relatives. And lastly, looking at these universals to get a better sense about actually what is universal amongst us. In other words, what are things that all humans share on the planet? And when we know that these things are there, we know that they're probably the result of evolution.